Three vertices of parallelogram PQRS are shown, where Q is 8, 5, R is 5, 1, and S is 2, 5. Place statements and reasons in the table to complete the proof that shows the parallelogram PQRS is a rhombus. So the first thing that we want to think about, or what I like to do, is to go ahead and graph it. So it will hopefully maybe help out a little bit. We see that all of ours are positive, so we're just looking in here. We have 8, 5, so 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5. So this would be like 1 point, and this is Q. And then 5, 1, so 1, 2, 3, 4, 5. And this is R. And 2, 5, so 2, then up 5. Now, using, it says Pythagorean theorem here. So if you wanted to think about the Pythagorean theorem, you know the Pythagorean theorem is a squared plus b squared equals c squared. You could see if this is a right triangle. Another way that I like to be able to solve it out in order to see is I like to use the distance formula actually. So you could use the distance formula. You could also, the way the Pythagorean theorem is helpful is because here you see that you would have to go, if you're at 2, 5 and you go down to 1, this side would be 4. This side would be 1, 2, 3. Using this method, we have a 3, 4, 5 triangle. So that means that this length would be a 5. I've always, whenever we do distances, used the distance formula, so that would have been my first thought to do. However, they tell us to use the Pythagorean theorem, and so that's kind of how it would work if you wanted to use that method. If you do that here to find the distance of these, whoops, this line's not that straight, but you would see that you, again, you're going down 4 and over 3, so this is 5 also. So here you could say then that SR equals 5. Or you could say that, so we have, this was S, so SR or RQ is 5 also. And the reasoning here would just be the Pythagorean theorem, because distance formula isn't one of the options, and if you recall, there are different ways of solving the same problem. So we can use Pythagorean theorem. You could have also used the distance formula though too, depending on your preference and what the options are. But here we will use Pythagorean theorem as our reasoning. Now, SR is equal to QR. So if we know they're both 5, they're equal to each other. That's substitution. Segment SR is congruent to segment QR. That's the definition of congruent line segments. Since they're the same length, we know that their segments would be congruent. PS is congruent to QR. We know that it's a parallelogram. It tells us right here that this is a parallelogram, so we know that we do have to have our other point up here, which if you look is the P, because P is the one that we're bringing in right now. And so therefore, with the properties of parallelogram, we know that you're going to have a P up here, and they're going to be congruent because of the properties that we learned with parallelograms. If PS, which is this side, is congruent to QR, which is this side, we also know that these two sides should be congruent as well. So that would be, it's really hard to see all my labels here, but we have SR. So here would be SR is congruent to PQ. Now let's see, and that is the way that they named it here, so that would be that option, so it does match our option. And the same reasoning, because our opposite sides are congruent, and so this again would be property of a parallelogram. Now, since we know that everything is congruent essentially, then we know that this is the definition of a rhombus. Using the Pythagorean theorem, we know that we have our 90-degree right angles if you wanted to check and everything. But we have proven now that our parallelogram is a rhombus based on the definition of a rhombus, because with the properties of parallelograms, we know opposite sides are congruent. They're also going to be parallel in this sense. So that completes our proof for here. If you have any questions, please let me know.